What is Henry's gas law and how do we use it? Henry's gas law essentially states that the concentration in molarity of the dissolved gas is equivalent to the pressure of the gas over the solution, multiplied by a number called the Henry's law constant, which is specific for each gas. So let's look at a problem. A bottled soft drink at 25 degrees Celsius has carbon dioxide gas at a pressure of 3.5 atm over the liquid. If the pressure of carbon dioxide in the atmosphere is 3.13 times 10 to the negative fourth atm, and the Henry's law constant for carbon dioxide over water at 25 degrees Celsius is 3.4 times 10 to the negative 2 molarity per atm, calculate the solubility of the CO2 both before and after the bottle is opened. So first, what do we know? Well, we're going to have to do this problem in two parts, since we have to calculate the solubility of carbon dioxide both before and after the bottle is opened. So starting with before the bottle is opened, what do we know? We know that the P, or pressure, is equal to 3.5 atm, as stated, and the Henry's law constant for carbon dioxide at 25 degrees Celsius over water is 3.4 times 10 to the negative 2 molarity per atm. Now we can use Henry's law and simply multiply these two values to solve for the concentration, or the solubility. Now that we've plugged in the values for P and KH into Henry's law, we can simply multiply these two together to solve for concentration, aka solubility. And we get 0.119 molarity. Now for after the bottle is opened, we know that the pressure will now equal the atmospheric pressure of carbon dioxide, aka 3.13 times 10 to the negative 4 atm, which is provided. The Henry's law constant will stay the same. Now we can multiply these two values together to solve for the solubility of CO2 after the bottle is opened. And we get about 1.06 times 10 to the negative fifth molarity. Let's take a look at another problem. What pressure of carbon dioxide is required to keep the CO2 concentration in a bottle of solid at 0.15 molarity at 25 degrees Celsius? Henry's law constant for carbon dioxide over water at 25 degrees Celsius is 3.4 times 10 to the negative 2 molarity per atm. So first, what do we know? So we're provided with the concentration C to be 0.15 molar. And we're provided with the Henry's law constant for carbon dioxide over water at 25 degrees Celsius, being 3.4 times 10 to the negative 2 molar per atm. We can now plug these two values into Henry's law and solve for pressure. Now we can simply divide both sides by the Henry's law constant to solve for pressure. And we get about 4.41 atm. Thanks for watching, like and subscribe.